So welcome you to today's lecture. So this is the fourth week of this course. I hope you are enjoying the course. In case you have any feedback about the course, feel free to write to me, or you can tell me during the lecture. Now, before I start today's lecture, as usual, let me ask you if you have any doubts from the last lecture or any of the previous lectures. Feel free to ask any of the doubts which may be bothering you. I have already uploaded the solutions of the first two assignments. The third assignment is already there. I guess we might have a quiz sometime later this week. So I would encourage you to do this homework also. Now this Wednesday, we don't have any lectures. So if you want, we can have, depending on your convenience, we can have a session, which I may call as a problem solving session, specifically for homework 3. So let me know if you want to meet on 26th. We can meet at a time convenient to all of us. Would you like to have a session on Wednesday for problem solving of homework 3? Otherwise, the tutorial would be only on Friday, and I guess our quiz is on Saturday. And then you might not have enough time to go through. So if you want, we can meet on 26th. Or we can meet tomorrow sometime if it suits you, because the last homework is based on the things which we did until last week, mostly last week. So let me know. If you would you like to have a session on Wednesday or tomorrow?
Sir, actually, today and as well as tomorrow, we have quizzes.
Okay.
So it is impossible for us.
So let me know if you write. You can always write me an email if you want to have any such session. All right.
Yes, sir. Sure.
Okay. So as I see there are no doubts, so then I can move on with my lecture. So we were doing ancillary statistics. Before that, we talked about minimal sufficiency, then ancillary statistic, and what we realized was that the sufficiency and ancillary are complementary ideas. Sufficiency is about reducing the data or considering a statistic which contains all the information about theta. And ancillary statistic is something which does not contain any information about theta. Then we saw that as such, although ancillary statistic alone may not have any information about theta, when it is used in conjunction with some other statistic, it might have information about theta, right? Through the dependence with the other statistic. So that led to the concept, or that led to the question, can we characterize situations where minimal sufficient statistic would be most successful in summarizing the data? And then it so turns out that the answer to this question depends on how much ancillary information a sufficient statistic carries. And that led to the concept of a completeness. So we gave a definition of a completeness. A statistic T is said to be complete if expected value of psi is 0 for any function psi for every theta. That should imply psi is identically 0. If that happens for a boundedly complete functions, I call such a statistic to be boundedly complete. Then we did one example. it says that let me just get this. Okay, so that led to this. Okay, now I have to. Okay. Let me just share the screen. Today I'm using my desktop, so the PDF version which I'm getting is not a very nice one. But anyway, I'll try to manage this. Okay, so then led to the example over here, which says that a boundedly complete statistic may not be complete. So this is an example of a situation where a family is boundedly complete, but it is not complete. As I said, if one has to show that it is boundedly complete but not complete, let me just show you through the board. So let me just stop this here and use the whiteboard. So the example which I am considering is f theta x as theta if x equal to -1, 1 minus theta square into theta to the power x if x equal to 0, 1, 2, and so on, and 0 otherwise. Theta is between 0 and 1. Let me use some other color for, okay. Then what I have to show is, claim is f theta, theta belonging to 0, 1. This problem I have given in the homework also is boundedly complete. But not complete. So suppose for that, let I have a function psi says that psi of x is 0 for every theta between 0 and 1. So let psi be such that happens. So what I have to show is if psi is bounded, that should imply psi is 0. If psi is not bounded, that should not imply psi is equal to 0 with probability 1. So let us see what it happens. X takes value -1 with probability theta, so psi of -1 into theta, plus then it takes value 0 to so on, so summation x equal to 0 to infinity psi of x theta to the power x into 1 minus theta square is equal to 0 for every theta between 0 to 1. This happens if and only if I keep this here as it is, psi x theta to the power x. I can multiply both the sides by 1 minus theta to the power -2. Then this will just go away, and this would be left with minus psi of -1 theta into 1 minus theta to the power -2. All right. Now, left-hand side is a power series in theta. If I can make right-hand side also a power series in theta, then I can compare the terms, because then I have two power series matching on an open interval, 0 to 1. And you know that if two power series match on an open interval, then their coefficients would be same. So that is what exactly I'm trying to do. So this is same as psi x theta to the power x is same as psi of psi of -1 theta. I expand 1 minus theta to the power -2. What is expansion of 1 minus theta to the power -2? You know from your basic calculus, this is 1 plus 2 theta, 3 theta square, plus 4 theta cube, and so on. So this is minus psi of minus 1, summation x equal to, power starts from theta is equal to 1, right? X equal to 1 to infinity. And then psi of x into theta to the power x. Right? This happens for every theta between 0 to 1. So I can make here, note that the for x equal to 0, what do you get as a coefficient of theta to the power x? Over here? Psi x. Let me see. Yeah. So what I can do is happens this way. So you can try to compare the coefficients on both the sides, because we have a 2 power series which are matching on both the sides. Coefficient of psi 0 over here is a constant term. So psi 0 would be 0, right? Because theta to the power 0, there is no theta to the power 0 over here. What is the psi 1? Psi 1 is coefficient of theta. Coefficient of theta over here is minus psi of minus 1. What is psi of 2? Which is coefficient of theta square. And coefficient of theta square here is nothing but minus 2 times psi of minus 1. What would be psi of 3? Psi of 3 here is a coefficient of theta to the power cube. And the coefficient of theta to the power cube over here is minus 3 psi of minus 1. So in general, what you get is psi of 0 is 0, and psi of x is same as minus of minus x times psi of minus 1. X equal to 1 to small. So let me just check. I hope I have admit. So let psi be a function such that x equals psi x is 0. That means psi of minus 1 theta plus summation x equal to 0 to infinity psi x theta to the power x 1 minus theta to the whole square is 0. That means summation x equal to 0 to infinity psi x theta to the power x is same as minus psi minus 1 into 1 minus theta to the power minus 2. That means psi x summation x equal to 0 to infinity psi x theta to the power x is same as minus psi of minus 1 theta 1 plus 2 theta plus 3 theta square plus 4 theta cube and so on. That is same as 1 minus psi of minus 1. Summation x equal to 0 to theta plus 2 theta square. Oh, I have made a mistake. There is no psi over here, right? Here you get x, so it will be x times theta to the power x, right? Because the coefficient of theta is 1. I have taken minus psi minus 1 common. Then coefficient of theta is 1. Coefficient of theta square is 2. Coefficient of theta cube is 3. So x theta to the power. Yeah. So now I am comparing the coefficients. So psi of 0, which is a coefficient of theta to the power 0. There is no theta to the power 0. So that is 0. Psi of 1. Psi of 1 is coefficient of theta to the power 1, which is minus psi of minus 1. Coefficient of theta square, so psi 2 is same as minus 2 times psi of minus 1. Psi 3 is same as minus 3 times psi of minus 1. So in general, psi x is same as minus psi of minus 1. Now, try to show that this would imply, if psi is bounded, then this would imply psi 0 is 0. If psi is not bounded, then you can find examples as that this is not 0. All right. I hope I have made, there is no error over here. Let me just go back to my problems and see 1 minus theta square, theta to the power x for x equal to, oh, sorry. The first one is x equal to minus 1, right? Let me, x equal to minus 1 with probability theta. So psi minus 1 theta, that is okay. And then x equal to 0 onwards, so on, it is 1 minus theta square into theta to the power x. The only thing is you just need to look at what is the coefficient of, what is an expansion of 1 minus theta to the power minus 2, right? So let us say if you have to expand h theta as 1 minus theta to the power minus 2, you can use the expansion around theta is equal to 0. So h theta is h0 plus theta times, sorry, h0 plus theta times h prime 0. Theta's expansion plus theta square by factorial 2 times h double prime 0 plus theta cube by factorial 3 h triple 0 and so on. Right? Now you can see that h0 is 1, h prime theta is minus 2, so 2 times 1 minus theta to power minus 3. So h prime 0 is 2. H prime 3 is 2 into minus 3, which is factorial 3 into 1 minus theta to power minus 4. This is h double prime theta, right? H double prime theta, 0. H prime theta is this. So what is h double prime 0? That is factorial 3 and so on. What would be h triple prime theta? Factorial 4 into 1 minus theta to the power minus 5. So h triple prime 0 would be factorial 4. So it would be h of theta would be h0. h0 is 1 plus theta times h prime 0. H prime 0 is 2. So 2 theta plus theta squared 2 times h double prime 0. H double prime 0 is factorial 3. Factorial 3 divided by factorial 2 would make it 3. So 3 theta square and so on. Right? So that is how you get. And then you equate coefficient and then you can get what your psi would be. Okay? So basically, actually this psi of minus 1 I should not take on the right hand side because that I can take only when psi of minus 1 is finite quantity. Right? You can take one quantity on the other. So I can keep psi of minus 1 on the one side itself. Right? I should not take it on that side. So this is psi of x plus, I have multiplied both the sides by 1 minus theta to the power minus 2. So psi of x plus psi of minus 1 theta into 1 minus theta to the power 2. Right? And then, you see, is it that clear why I'm not taking it on the right hand side? Because a plus b is equal to 2 would imply a is equal to 2 minus b only when b is finite. I do not know whether psi is bounded or not, right? Psi may not be bounded, so I don't take it on that side. I keep it here only. So what you get over here is, this is same as psi x plus psi of minus 1 theta, 1 plus 2 theta plus 3 theta square plus 4 theta cube and so on. So, and then from here, you can just coefficient. So this is equal to 0. So the coefficients would be 0, right? So let us look at first the coefficient of theta to the power 0. So that means psi 0 is 0. Then coefficient of theta to the power 1. So that is psi of 1 plus psi of minus 1 is equal to 0 and so on. Then you can keep on solving it. Try to do that. I have given you enough hint to this problem. So for the bounded function psi, you saw that it would imply psi 0 is 0. Psi theta is 0 for every theta. Otherwise, it will not be. Is that clear? Okay, so let me stop this here. Now let me go to the Is that example clear? So this fact that two power series match on an interval would imply the coefficients are same would be used in many examples. So this problem I have given you as a homework problem also. So try to do that. Just a subtle point is left over there, and rest of the problem I have solved, in fact, for you. Okay, so now let us go to the. Then I gave a definition of a complete, boundedly complete, and then I took a lot of examples. This example also I have given in the homework. Now, I think, yeah. My screen is frozen, so let me just stop share and again I'll do it. Oh no, there's some serious issue with my desktop today. Screen sharing has stopped. I said, okay. So let me see if I can. Okay, so let me. Yeah, it's frozen. I need to. Let me see if I can manage. So you see, today I am just using my desktop, and see there's some issue with desktop today. Yeah, so I give the definition of a completeness. Then I took few examples of completeness. Then this example, which is also given in the homework, that x1, x2, xn be IID with PD of f theta x given by 1 by theta if x belongs to 1 to theta. So it is a discrete uniform distribution on the set 1 to theta. Theta can take any integer value so that the family of theta is complete. So the full family is complete. But if I take out just one single point from this theta, your family no longer becomes complete. So just taking out one element from the parameter space makes the family from complete to incomplete. And so that maximum of x1, x2, xn is complete. I don't know. I'm just stuck with this. What I'm going to do is, I think I see there is some issue with my desktop today. So let me just log out from my desktop. I'll try to log in through my laptop. I'll just connect in a few seconds. Just give me some time.